Hi friends, today we will discuss working principle of Tesla Model Y electric vehicle. This consists of a battery, a DC to DC converter, an inverter and PMSYNREL motor. So this reaches 60 miles per hour in 3.5 seconds. It uses a high efficient motor. It has high starting torque and it uses a heat pump for cabin heating rather than a resistive type of electric heater. Its first delivery was given in the year 2020. It uses a 384 HP motor which has a torque of 510 Newton meter. The battery voltage is 400 volts. So this is the inverter used in this vehicle for controlling the speed of the motor. To control the speed of the motor, we control the frequency. In an inverter, output frequency is equal to triggering frequency. So the triggering frequency is controlled by the microcontroller. This is similar to coach and player. If coach is running faster, the player will be running faster. If triggering frequency is high, output frequency is high. So whenever I accelerate my vehicle, the frequency will increase, speed will increase, and vice versa. So the type of motor is PMSYNREL motor. The PMSYNREL motor is a combination of synchronous reluctance motor and permanent magnet synchronous motor. So we'll separately see reluctance motor, then we'll separately see PMSM, then PMSYNREL is a combination of these two types of motors. So these magnets you find in permanent magnet motor, and this type of variable reluctance structure you find in reluctance motor. So higher output power because you get reluctance power and also synchronous power, high efficiency when compared to induction motor and PMS. Hence Tesla has started with induction motor, then moved to permanent magnet synchronous motor, and now they are using PMSYNREL, which is combination of permanent magnet motor and synchronous reluctance motor. So to understand this reluctance power, we have to know Blondel's two reaction theory. Blondel says you have to treat polar axis separately and interpolar axis separately. Polar axis is called D axis and interpolar axis is Q axis. Along the D axis, flux is maximum, inductance is maximum, reluctance is maximum. Along the Q axis, flux is minimum, inductance is minimum, reactance is minimum. So XD is always greater than XQ. So this is 4-pole rotor of reluctance motor. This is polar axis where notch is there, that is interpolar axis. So this is the rotor of synchronous reluctance motor. You have both stator and rotor. Stator is shown here and rotor with that variable reluctance structure is shown. In this region flux is maximum, in this region flux is minimum. Reluctance power is given by the expression some constant into xd minus xq into sine 2 delta. So this power you get in this machine because xd is different from xq. In a round rotor synchronous machine or cylindrical synchronous machine, xd and xq are equal. You will not get this type of power. So this has simple construction since there is no rotor winding, no rotor copper loss, and it is robust. Now let us come to the second type of motor, that is permanent magnet synchronous motor. The stator has 3 windings displaced by 120 degrees. Ferrari says when you apply 3-phase balanced voltage to this stator, a rotating magnetic field is produced. And the rotor gets locked to the rotating magnetic field, and your PMSM works on the principle of magnetic locking. So in a successful married life, husband gets locked to the wife and runs synchronously with the wife. In PMSM, all the waveforms are sine wave and the harmonics are less and losses due to harmonics are less. So the power in PMSM is VE by X sine delta, and The power in PMSYNREL is combination of this and previous equation. So V by x sine delta plus k into xd minus xq sine 2 delta. Hence you get higher power. So how do we get regenerative braking in this? Whenever you want regenerative braking, you reduce the inverter frequency. So when you apply a brake, the frequency of the inverter is reduced, delta becomes negative. Delta is the angle between stator field and rotor. Because you reduce the inverter frequency, the speed of the field in the stator gets reduced. Due to inertia, rotor continues to run at the same speed and delta becomes negative. When delta is negative, power is negative. In motor operation, delta is positive, power is positive. And in generator operation, delta is negative and power is negative. So this acts as, machine acts as generator. If I don't give pulses to the switches, then all the 6 diodes together will act as a diode rectifier. Then AC power is converted into DC that charges the battery. If you want to control that regenerative power between the battery and inverter, you can keep a bidirectional DC to DC converter. Thank you for your patience and please subscribe to my channel Ramareddy Sathi.